Good morning, friends. Today, class 8, exponents and powers concept we'll discuss. Okay, in non-zero rational number considered as A. A is a non-zero. That means A is not equal to 0. And a rational number. A belongs to a rational number. A is rational number. Of course, A is not 0. Is multiplied by itself. That is nothing but A into A. We learned this is A square. Suppose if A into A into A, we learned in cubes and cube roots A cube. If it is multiplied by 4 times, if it is multiplied by 5 times, if it is multiplied by 10 times, how many times? 10 times. If it is multiplied by 100 times, 1000 times, 999 times, so on, okay, into A, like n times, then what will happen? Okay. Now, if it is multiplied by 4 times, then we will call it as A to the power of 4. If it is multiplied by 2 times, A square or A power 2. A into A cube we are telling. Actual the meaning is A to the power of 3. A is raised to 3 times. A to the power of 4. Now it is A to the power of 5. Now it is multiplied by 10 times. A to the power of 10. Finally, we came to know A to the power of n. Okay. Now see A to the power of n. A to the power of n. In this, we are telling A to the power of n. A is a non-zero rational number. What is n? It can be 1, 2, 3, 4, so on. It is a natural number. A is a natural number. Then it is called, n is known as exponent. Okay? N is known as exponent. And A is known as base. A is known as base. So, if A power n, then A power 10, A power 5, A power 4, like that, so on. Now, you can get some number of questions in our mind right now. You are telling n is natural number, n is exponent. So, what happened A to the power of minus 3? Might be you learned in 7th standard. Why are 2 power? A instead of A, I am telling 2. Suppose 2 into 2. 2 square. 3 into 3 into 3 into 3 into 3. Now it is 3 to the power of 5. Like that, why can't 2 to the power of some 5 by 7? Or why not 3 to the power of some root 2? Or 7 to the power of some 0.5? Yes, we all discuss by this end of the chapter. I will clear all such doubts, okay, by end of this chapter. So slowly we are learning. First we are learning about if n is a natural number. Then we will come to A, right, integer. A, rational number. A, irrational number. So, powers, that means, that's why the chapter name is exponents and powers. If n is a natural number, then it is called exponent. Suppose A to the power of 10, A is multiplied by 10 times. 5 to the power of 7, 5 is multiplied by 7 times. 6 to the power of 8, 8 is multiplied, 6 is multiplied by 8 times. 6 into 6 into like 8 times. Now, my question is, 7 to the power of 0.5. Right? So, this type of questions will come to an end. By end of this video, you'll come to an answer. Now, we'll discuss laws of exponents. Okay. So, suppose if 3 to the power of 2 is multiplied by some 3 to the power of 5 is there. What is the answer? So, what is minimum basic of this 3 to the power of 2? That means 3 into 3. 3 to the power of 5. 3 into 3 into 3 into 3 into 3. If you multiply together, how much we are getting? That's the answer he is asking, right? So, here, then 1, 2, 3, 4, 5, 6, 7 times I should multiply. Can I write 3 to the power of 7? Right? Suppose, now my next question is 5 to the power of 4. 5 to the power of 2 will be how much? Now, that means 5 I should multiply 4 times. 5 I should multiply 2 times. Now, the answer is how much? So, totally, at the end, at how many times I should multiply? 1, 2, 3, 4, 5, 6. Right? So, 5 to the power of 6. Okay. Now, without expanding, can we write directly here? Right. If bases are equal, power should be added. Okay. What is the word here I can write? Bases are equal, power should be added. Bases are equal, powers should be added. This is your first law. Bases are equal, power should be added. Then if that is the case, 3 to the power of 2 plus 5, 3 power 7. 5 to the power of 4 plus 2, 5 power 6. So, by help of this, we are writing the first formula is a power m into a power n. A can be 3 or 5 or 7, whatever it may be. Power can be anything. A to the power of m into n, a power m plus n. A to the power of m plus n. Then this one we can extend. The powers may not be natural numbers. Suppose 5 to the power of minus 3 into 5 to the power of 2. Then it can be written as a power m into a power n, a power m plus n. 5 to the power of minus 3 plus 2, 5 to the power of minus 1. Suppose one more I will write here, that is some 3 power 1 by 2 into 3 power 1 by 2. Bases are equal, power should be added. So 3 to the power of 1 by 2 plus 1 by 2, 3 to the power of half plus half is 1. Okay, I can take one more example also, like 7 to the power of 0.25 into 7 to the power of 0.36. So, 7 to the power of 0.25 plus 7 to the power of 0.36. If bases are equal, power should be added. So, 7 to the power of 6 plus 5, 11, 1, 3 plus 2, 5 plus 1, 6, 0.61. Okay. So, finally, we came to first formula, that is a to the power of m into a to the power of n is equal to a to the power of m plus n. Okay. Now, second exponent, law of second rule. Okay. So, a to the power of m by a to the power of n. Some examples we will do. 5 to the power of 7 by 5 cube. Okay, let me expand. So how many times I should write? 7 times. Okay, 5, 6, 7. By denominator, 3 times. Okay, let me cancel 1, 2, 3. So how many times is left? 4 times is left. So numerator 7 times is there. Okay, see, numerator 7 times is there. Denominator 3 times is there. Out of 7 times, if I subtract 2 times, total 4 times is left. So division is nothing but subtraction. Division is nothing but subtraction. We'll check with one more example. Suppose 3 to the power of 5 by 3 to the power of 2. So 3 into 3 into 3 into 3 into 3 by 3 into 3. Cancel 3 cube. Okay, so here I can write this one is 5 to the power of 7 by 5 to the power of 3. Can be written as 5 to the power of 7 minus 3. Or else 3 to the power of 5 by 3 square can be written as 3 power 5 minus 2. That is nothing but 3 power 3. Here also 5 to the power of 7 minus 4. 5 to the power of 4. Yes. So the same way a to the power of m by a power n can be written as a to the power of m minus n. This is your second formula. With help of this second formula, we can create or we can generate a different formula. Okay? A different example consisting of a power m by a power n. Okay? See, 2 cube by 2 cube. That means what? 2 into 2 into 2 by 2 into 2 into 2. 2 into 1 time cancel. So 1 is the answer. Suppose 3 power 5 by 3 power 5. 3 is multiplied by 5 times. Again denominator 5 times. Cancelled 1 time. So what can we say here? If both the numerator and denominator are same, that means a power m by a power n, the value is equal to 1 when m is equal to n. When m is equal to n. And here one more rule also we can say. Okay, one more formula also we can derive. That is, okay, let me take one example. Suppose 2 power 5 by 2 power 5. That means we are telling this value is 1. Both numerator and denominator value is 1. The same formula if I apply this, a power m by a power n. So 2 to the power of 5 minus 5, numerator and denominator. This is m, this is n, m minus n. The value should be become how much? 1. 5 minus 5 value? 0. That is 1. So, what is our first basic principle? A power n. A is non-zero rational number. A base cannot be 0. That means we can derive now 3 to the power of 0 is 1. 5 to the power of 0 is 1. 99 power 0 is 1. So simply we can claim to know a formula derivation. Okay? That is a power 0 is equal to 1 when base cannot be 0. That is our basic principle of exponents derivation. A power n. A is a non-zero rational number. A cannot be 0. Now we derived one more formula, that is a power 0 is equal to 1 when a is not equal to 0. We derived this formula. From this formula, a power m by a power n is equal to a power m minus n. If both numerator and denominator are same, then they are equal. Okay? Now, one example also we will do here. Okay? Now, here a power m, a power n. Numerator power is m and denominator power is n, where m and n are powers. These powers are two different numbers or equal numbers. If it is equal, the answer is 1. If it is different, that is nothing but it is called as law of trichotomy. If any two numbers will exist, that is, if first number is greater than the second number, first number is equal to the second number, and first number is less than the second number. Other than these three parts, there is no other value you can include in between m and n. Whether m is greater than n, m is equal to n, m is less than n. Okay? Now, if m is greater than n, m is greater than n. So 2 to the power of 5 by 2 to the power of 3. Now, what is m here? M is 5. What is n here? N is 3. So 5 is greater than 3. So m is greater than n. So that is my first one. Okay. Now the second one. Suppose 2 to the power of 7 by 2 to the power of 7. So what is m here? 7. What is n here? 7. Then m is equal to n because 7 is equal to 7. 7 is equal to 7. So whenever they are equal, we are telling this answer is 1. Whenever they are not equal, then we are telling that 2 power 5 minus 3, 2 power 2 we are getting. So we are getting a positive answer here. If m is less than n, did you understand my point now? That is nothing but, suppose 2 to the power of 3 by 2 to the power of 7. 2 to the power of 3 by 2 to the power of 7. How it will come? 2 into 2 into 2 by 2 into 2 into 2 into 2 into 2 into 2. 7 times if I write, 1, 2, 3 times cancel. So in denominator, 2 to the power of 4 is left. So a power m by a power n formula. A power m by a power n formula. We have three different formula we have. One is, if m is greater than n, then a power m minus n. If m is equal to n, that is a power 0, answer is 1. If m is less than n, denominator we are getting 4, that is 7 minus 3, that is 1 by a to the power of n minus m. Okay? So this formula have three different cases are there. Case 1, case 2, case 3. So finally, I am concluding this. A power m by a power n value is how much? Formula a power m minus n when m is greater than n. A power m by a power n value is 1 when m is equal to 1. A power m by a power n is equal to 1 by a power m minus n when m is less than n. Now, but here I want to quote one more formula. That is, if both are equal, m minus n will become 0. A power 0 is equal to 1 for all a not equal to 0. Here this is the symbol for all. That means for everything a denominator, that is base, should not be equal to 0. So Now we learn 4 laws of exponents. The first one is a power m into a power n is equal to a power m plus n and a power m by a power n. 3 different cases are there. M is greater than n, m is equal to n, m less than n, and a power 0 value is equal to 1. Okay, bye.